Hello viewers, my name is Dr. Ajay, Department of ECE, Associate Professor from the Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today we are going to discuss about the problems on radiation resistance and beam width. So today we are going to discuss the problems on radiation resistance and beam width. So these problems are related to the course Antennas, Waves and Propagation. So these problems are related to the course antennas, waves and propagation. So we are going to discuss about the problems on the radiation resistance and the beam width. Let us start our session. An antenna has a radiation resistance of 73 ohms and a loss resistance of 7 ohms. If the power gain is 20, calculate the directivity and efficiency of the antenna. So the radiation resistance is given as 73 ohms. It is, let us say, denoted by the symbol RR. So the radiation resistance of an antenna is denoted by the symbol RR. So RR is nothing but radiation resistance denoted as 73 ohms. The loss resistance it is given as RL is equal to 7 ohms. RL is equal to 7 ohms. Also the power gain it is given as GP denoted by the symbol GP is equal to 20 here. So from the data given here, the radiation resistance it is 73 ohms. RL the loss resistance it is equal to 7 ohms. The power gain it is given as 20 which is denoted by the symbol GP. So from the data given we know that the radiation resistance and the loss resistance are not in dB or not in the dB here. So here the GP the power gain is expressed in dB in the problem here. So we need to convert this GP dB value into decimal value like RR and RL. So here 10 log GP base 10 is equal to 20 we can write here. So here log GP base 10 is equal to 20 by 10. So you will get 2 here. So if you substitute here GP, sorry, the power gain is it is mistake here. 12 dB here. The power gain is given as 12 dB here. For the 12 dB, let us calculate. It is not 20 here. Let us calculate the 12 for the 12. Here, if we take 12 value, the GP is given as so here GP it is given as 20. 12 dB here. We know that 10 log GP is equal to 12 base 10 and log GP base 10 this is equal to 12 by 10 here. This is equal to 1.2. So GP is equal to 10 power 1.2 which is given as 15.85 here. So GP is taken as 15.85 here. So we know that the efficiency is of the antenna is given by RR by RR plus RL. So we know that the efficiency of the antenna is given by RR plus RL here. So if we substitute here RR, so RR is given as 73 by 73 plus 7 here. So it is given as 73 plus 7 is equal to 80 here. So 73 by 80 it is nothing but 0.9 here. So efficiency is given as 73 by 80 it is nothing but 0.9 here. So this is the efficiency of the antenna. And similarly we can calculate the directivity D. So there is a relationship between the power gain and the directive gain as GP is equal to eta GD. So there is a relationship between the GP and eta GD here. So GP is nothing but it is we know that 15.85 and efficiency we got as 0.9 here. And we need to calculate the directivity. So GD is equal to 15.85 divided by 0.9 here. So 15.85 by 0.9 here. So if you substitute here 15.85 by 0.9, so you will get the value of GD as 12.45 dB. So GD is equal to, you will get 12.45 in dB. So you will get a decimal value is equal to 17.60. We need to convert this GD again into the dB value. That is 10 log 17.6 is equal to 12.45 dB. So this is about the problem of 4. We need to calculate the directivity. So the directivity to calculate, we need to know the value of a power gain in terms of decimal value and also the efficiency. So GP is equal to eta GD. So 15.85 is equal to 0.9 into GD. So GD is equal to 15.85 by 0.9, that equal to 17.6. This is decimal value. So we need to convert the directivity into the decimal dB value. So we do that 10 log 17.6 is equal to 12.45 dB. So this is a problem here. You can see here efficiency is equal to RR by RR plus RL, that equal to 72 by 72 plus 8, that equal to 0.9, and GP is equal to 12 dB. It is given as 12 dB. So 10 log GP is equal to 12. You will get GP is equal to 15.85, the decimal value. And there is a relationship between the power gain and the directivity. GP is equal to eta GD. If you substitute the GP value on the eta, you will get the value of GD here. So GD is equal to 17.6 you will get, which we convert into dB, you will get 12.45 dB here. Now let us go for the second one, the problem 5. So an antenna has a field pattern given by E of theta is equal to cos theta cos 2 theta, where theta lies between 0 and 90. Find half power beam width and beam width between the first nulls here. So the field pattern is given by the equation E of theta is equal to cos theta cos 2 theta, where theta is less than 0 to 90 here. So here we need to find out the half power beam width here. So half power beam width means the power taken exactly half of the maximum point of the maximum power of the major lobe. The power taken exactly at half power points of the major lobe, we call it as a half power beam width. So if we substitute here, let us say this is a major lobe. These are known as half power points. These are known as half power points. If we join these two lines, the angle so formed here, we call it as half power beam width. So the power or the angle between half power points of the major lobe, we call it as the half power beam width, and the power, the half power of the major lobe is generally 1 by root 2 times. It is 1 by root 2 of the major lobe. So the power exactly on the half power points is taken as 1 by root 2 here. So as per the equation given, we know that cos theta, cos 2 theta, this is equal to 1 by root 2 it is given. Why? Because the power is only 1 by root 2. So from this equation, we can find out cos 2 theta is equal to 1 by root 2 into cos theta you will get. So 1 by root 2 into cos theta. So cos 2 theta is equal to 1 by root 2 into cos theta. So what is 2 theta? So 2 theta is equal to 1 by root 2 cos theta into cos inverse. So you will get 2 theta is equal to, you will get cos 2 theta, you will get 2 theta is equal to cos inverse of 1 by root 2 into cos theta. So what is theta here? Theta is equal to 1 by 2 cos inverse of 1 by root 2 into cos theta here. So here we need to find out the value of theta. We need to find out that this is the value of theta. Let us assume this as theta dash here, and this is theta here. So when you, by substituting different values of theta, you will get a theta dash value. So there are two values of theta. One is theta and theta. Let us assume one theta as the theta dash here, So here theta dash, let us assume. So here let us assume theta dash is equal to 1 by 2 into half cos inverse of 1 by root 2 cos theta here. Now let us iterate. That means we randomly substitute some values to the theta and find out the value of theta dash here. So here let us assume here this has theta dash and this has theta here. This is theta dash here and this is theta dash here. Now let us assume theta dash has 0 here. Assume theta dash has 0. So 1 by 0 is equal to infinity. So 1 by 0 is equal to infinity. So you will get theta is equal to 22.5 degrees in it. 5 degrees here. So we randomly substitute the value of theta dash here. Theta dash is equal to 0. You will get theta is equal to 22.5. So for theta dash is equal to 0, you will get theta is equal to 22.5. Now if you substitute, let us set now theta dash as 22.5. Theta dash as 22.5. So now for theta dash is 22.5, you will get value, what is the value of theta? So you will get the value of theta as 20.03. 20.03 here. So here cos theta and cos 2 theta is equal to 1 by root 2. So cos 2 theta is equal to 1 by root 2 into cos theta dash here. So here we got theta is equal to 20.03. Again, this is the first iteration. This is the second iteration, and here this is the second iteration. And in the third iteration, what we need to do is substitute theta dash is equal to 20.03 and find out the value of theta here. Find out the value of theta. Now repeat the iteration till theta dash will be equivalent to theta value. So let us equate, let us simplify again here. Let us assume this as a cos theta here, root 2 into cos 2 theta is 1 by root 2 into cos theta. Assume this as theta dash here. So 2 theta is equal to, you will get cos inverse of 1 by root 2 cos theta dash here, and the theta is equal to 1 by 2 cos inverse of 1 by root 2 cos theta dash. So we should find out the value of theta by substituting theta dash as some random values. So if you substitute theta dash is equal to 0, you will get theta is equal to 22.5. So when you get 22.5, substitute in theta dash again. When theta dash is equal to 22.5, you will get theta is equal to 20.03. And if you substitute theta dash is equal to 20.03, you will get theta is equal to 20.47. So like this, you need to start the iteration process a number of times till theta dash is equal to theta. So we get the value of theta dash is equal to theta at 20.5 degrees. So after a few iterations, after first iteration, second, third, fourth and fifth iterations, after a few iterations, finally the value of theta and theta dash will be equal at 20.5 degrees centigrade. So 2 theta is equal to, we will get so theta is equal to 20.45. So what is 2 theta? 20.45 into 2. 20.45 into 2 is equal to 41 degrees approximately. So this is the half power. This is the half power beam width value. This is the half power beam width value here. Now let us simplify the same by setting the beam width between the first nulls. Beam width between the first nulls. So to find out beam width between the first nulls, we need to set the E of theta as 0. We need to set E of theta as 0. So cos theta, cos 2 theta is equal to 0. And cos 2 theta is equal to, if substitute here cos theta is equal to 0, you will get cos 2 theta is equal to 0. So theta is equal to 45 here. So beam width between the first nulls 2 theta is equal to 90 here. So beam width between the first nulls 2 theta is equal to 90 we are getting here. So this is about how to simplify to find out the value of half power beam width and also beam width between the first nulls here. Similarly, we can try another problem in the similar fashion. A lossless half wave dipole antenna with input impedance of 73 ohms is connected to a transmission line whose characteristic impedance is for 50 ohms Assuming that the pattern of the antenna is approximately given by U is equal to B naught sine cubed theta, find the maximum absolute gain of the antenna here. So we need to find out the maximum absolute gain of the antenna here. So assuming that the pattern of the antenna approximately given as U is equal to B naught sine cubed theta. So we know that D is equal to pi max by pi AV here. So D is equal to pi max by pi AV here. So here pi max it is given as B naught sine cubed theta here. So we can write pi max as B naught sine cubed theta here. And we need to find out the value of pi AV. What is pi AV here? Pi AV is equal to, we know that W by 4 pi here. So pi AV is equal to W by 4 pi here. So we need to find out the W here. So what is W here? Integration of pi d omega. So we need to find out the value of pi here. So you can see, you can simplify here. Here D is equal to pi max by pi AV, and pi AV is equal to W by 4 pi, and W is equal to integration of pi d omega. Here, as per the data given, pi max is equal to B naught sine cubed theta it is given. B naught sine cubed theta it is given. So here let us substitute first the value of W here. So we know that d omega is equal to ds by r square. So this is equal to sine theta d theta d pi. This is indicated in terms of steradian here. So W is equal to, we can find out B naught sine cubed theta, B naught sine cubed theta into sine theta d theta into d pi here. So if you substitute here B naught into sine power 4 theta d theta d pi here. So integration of d pi. So you will get 2 pi B naught integration of sine power 4 theta d theta here. So 2 pi B naught into sine power 4 theta d theta. Why? Because integration of d pi this is equal to 2 pi. So why? Because we are going to integrate with the integrations of 0 to pi, integration of 0 to 2 pi here. So integration of 0 to 2 pi d pi is equal to 2 pi unit. So hence we got the value of 2 pi here. So if you simplify this, you will get you need to find out the value of integration of sine power 4 theta under d theta. And now we know that d is equal to pi max by pi AV. We need to find out the value of d here. So if you simplify here this, you will get approximately 16. So here, if you simplify this, d is equal to pi max by pi AV. So d is equal to nothing but 4 pi into pi max by, you will get pi AV. Sorry. So d is equal to pi max by pi AV here. So what is d? D is equal to pi max by pi AV means w by 4 pi here. So you will get 4 pi into pi max by w. So here what is 4 pi? What is pi max value? You will get b naught sine power 3 theta. This is pi max by, if you simplify this, w, you will get 2 pi b naught sine power 4 theta d theta. So here b naught get cancelled and 2 pi get cancelled, you will get 2 here. So b naught get cancelled here. So sine cubed theta by sine power 4 theta d theta. If you simplify here, you will get 16 by 3 pi. So this is equal to 1.697 here. So you will get 1.697 here. So this is the directivity. We need to find out the maximum absolute gain of the antenna, whose efficiency is given as k is equal to 1 here. So here we know that G naught is equal to KD here. So the efficiency is, if we consider the antenna as lossless antenna, the efficiency will be equal to 1. So G naught is equal to 1 into, we'll get 1.697. So G naught is equal to, we'll get in terms of dB, 10 log 1.1697. So this will get 2.297 here. 2.297 here. So this is about the problem. So we need to find out the value of this integration value. So total will get 16 by 3 pi. If we simplify mathematically, we'll get 1.697 here. So these are the problems based upon the radiation intensity and the radiated power. And here, let us discuss some more problems. Today we have discussed about the problems on the absolute gain of the antenna, the half power beam width, and the beam width between the first nulls. So also the directivity and the efficiency of the antenna here. So let us close our session today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.